Hi everyone, so here's my worked solutions to those three hypothesis testing past paper questions. Okay, so question 1. Past records suggest that 30% of customers who buy baked beans from a large supermarket buy them in single tins. So this is going to be our 30% here. That's going to be our probability of success if nothing's changed. So there we go. A new manager questions whether or not there's been a change, and again, the wording here is really important. It's a change. It's not an increase or a decrease. It's a change. So that means it's going to be a two-tailed test. So a random sample of 20 customers who'd bought baked beans was taken. Part A then. Using a 10% level of significance, find the critical region for a two-tailed test. Well, even if they hadn't told us that, we know that because of the wording. To answer the manager's question is, has there been a change in the proportion of customers who buy them? So has this changed from 30%? Is the probability of success changed from 0.3? So we need to work out some statistics to see if we've got any evidence for that. Okay. And it says we should state the probability of rejection in each tail, which should be less than 0.05. So we're looking at this, which is our two-tailed test at 10%. Okay. So let's have a think about this. It's telling us here that it's going to be, they buy baked beans in single tins or they don't. So it's a binomial distribution. Our sample size n is 20 and our probability of success is 0.3. So that's what's happening if there's been no change. The probability of success, 0.3. So what's our hypothesis? Our hypothesis then, our null hypothesis, is nothing's changed and the probability of success is 0.3. Our alternative hypothesis is that there has been a change, so not equal to. Okay, so there's been some change there. Okay. It wants us to find the critical region, so let's have a think about a number line here. It starts at 0, there's 20 in this, and it wants us to find a critical region, so we're looking for our values C1, where the probability here then at this lower end of being less than or equal to C1, we want that to be less than or equal to 5% because it's a 10% level of significance, but it's a two-tailed test. So it's going to be 5% at the top end, 5% at the bottom end. So that's what we're looking for down here. And then at the top end, we're looking for, again, this tail end to be less than or equal to 5%. So the probability of being bigger than or equal to some value C2, it's just got this little bit here at the top end. And everything else, this 90% in the middle, what that's going to mean is that if we get one of those values, we haven't got evidence to say that there's been a change. There's a reasonable probability here of these values happening. But if I'm in this region, then there's not a very high likelihood of it happening, less than 5%. And if in this region, again, not a very high likelihood of it happening, less than 5%. So we're saying then that there'll be evidence that there's been a change. So let's have a look at using our calculators to find these two regions. Okay, so for this one, the probability that x is less than or equal to C1, I want that to be less than or equal to 5%, so 0.05. So on our calculators, we're looking at the binomial CD, cumulative, because it's less than or equal to, not equal to, less than or equal to, so cumulative. And I'm going to look at my list because I want to find the value of x that gives me a probability less than 5%. And I can go all the way from 0 to 20, or I can just type in the first few and have a look. And if I don't get one, I can carry on typing in a few more and keep going. And don't forget with this, quite often people forget to put 0 in. We've got to put 0 in as a value. There might be nobody that does this, so we've got to start at 0. So let's just put a few of these in. Our n is 20, and our probability of success is 0.3. And I'm not sure if you can see these, but basically here, the first one here, excuse me, that gives me a probability less than 5%, less than 0.05, is 2, and that's 0.0354. So the probability that x is less than or equal to 2 is 0.0354. The next one up from that, let's just put it down, less than or equal to 3 is 0.107. So that's no good to me because it's bigger than 5%. So this is the one that I want. So what does that mean? It means my C1 is equal to 2. So my critical region at this bottom end is if ever x is less than or equal to 2. So if I'm in there, the probability that happened is less than 5%, and I'm saying then there's evidence to say there's been some change here because it's not very likely. Okay, let's have a look at the top end, see if we can remember how to do this. So the probability at this top end of x being greater than or equal to C2, we want that probability to be less than less than or equal to 0.05, 5%, because here, let's not forget, it's binomial, so it's discrete, so there's nothing between C2 and this value 1 below it. There's nothing in here. So if I want this region, then it's going to be 1 minus everything less than or equal to the number before. So that means this is going to be 1 minus the probability that x is less than or equal to C2 minus 1. And I've got to do that because my calculator will only give me a less than or equal to probability. So rearranging this, 0.95, take my probability over there to keep it positive. So reading that way, the probability that x is less than or equal to C2 minus 1, I want that answer to be less than or equal to 0.95. Okay, and you know, I typed a few in before, so I'm going to type a few more in now. I've only got to go from 0 to 20, so I could type them all in. Let's have a look. Type in a few more of these in. I'll have a look at my probability, and if I haven't hit it by the time I get to that value, again, I'm not sure you can see because it's quite small, but actually here I am going to hit it. So probability, if I just write these in, the probability that x is less than or equal to 8 is 0.8866, so that would be okay. But let's see the next one. Probability less than or equal to 9 is 0.952. Now actually that's too high, so there, because it says here it should be less than 0.095, so I want this to be less than 0.95. Sorry, I can see I've made a mistake there. Let me go back. Just reading that way, hopefully you picked up on that. Reading that way, that should have been a greater than or equal to. So actually now this one's no good to me because it's less than 0.95. This one's pretty close and it is greater than or equal to. So sorry about that little mistake there with the inequality sign. So probability that x is less than or equal to 9 is the first one that gives me this. So what does that mean? It means C2 minus 1 is equal to 9, taking that over then, so C2 is equal to 10, so my critical region here, this value is 10, my critical region is x is greater than or equal to 10, because if I'm in there, then I'm going to get a probability bigger than 95% for this bit, so this little bit here, probability of x is greater than or equal to 10 is going to be less than 5%. So my critical region overall I can either be in x being less than or equal to 2 or x being greater than or equal to 10. And if I'm in either of those regions, then I'm saying the probability of those happening is pretty small if nothing's changed. So there's evidence at the 10% level of significance that actually there has been a change to this. Okay, so we found our critical region, we've got our 5 marks there. Let me just get another piece of paper. So now, let's just move this up. Hopefully you can still see that. It now says, write down the actual significance. So write down the actual significance. So if I just get my other piece of paper back to have a little look at this, if I look at this here, my actual probability here was quite a bit less than 5%, 0.0354. And here, my actual probability of being greater than or equal to 10, so that's 1 minus the probability of being less than or equal to 9, 1 minus my 0.952 from my calculator here, so then the probability of that is 0.048. So these two values now are my actual probability of being less than or equal to 2 or being greater than or equal to 10. So for part B of the question, write down the actual significance, what that is I can either be less than or equal to 2, or I can be greater than or equal to 10. So that's going to give me the probability less than or equal to 2, 0.0354, or the probability of being greater than or equal to 10, 0.048. So my answer there, 0.0834. Okay, or you might get something that rounds slightly differently to this, but it's always going to be more or less that value. Okay, so that's what it means when it's asking for actual significance. Okay, let's have a look then now at part C of this question. So part C of this question says, the manager found that 11 of the customers out of the 20 had bought these baked beans in single tins. Comment on your finding in light of your critical region. My critical region is either my value needs to be less than or equal to 2 for me to say there's been a change, or it's greater than or equal to 10. So we can see there that 11 is definitely in the critical region, because it's in the critical region of that top end, because it is definitely greater than or equal to 10. So what we can say there is evidence at the 10% level of significance, because we've done a 10% level two-tailed test, that there's been a change. And we're doing this in the context of the question, so there's been a change, or we could say increase because we're at the top end, I suppose, but there's been a change, not to do the wording of the question, in the proportion, or the number, doesn't need to be proportion, you could say number, of customers, what were they doing, buying single tins of beans. Because what we're saying here is there's evidence to reject H0, which is the null hypothesis, which would have mean nothing had changed. So there's evidence there to reject H0 and accept H1. But what you must do in these questions is not just write this. You can write this, that's fine, but you need to then give some context to the question. What is the question actually about? This one's about a supermarket and people's buying of baked beans. Okay, so that's question 1 done. So let's have a look at question 2. So question 2 here. In a region of the UK, 5% of people have red hair. Okay, so 5% of people have red hair. So there's our probability of success. In this case, success is the person's got red hair. So P is equal to 0.05. In a random sample of size n taken from this region, the expected number of people with red hair is 3. Okay, calculate the value of n. So part A, it's saying that basically 5% is equal to 3 people. So we're looking for 100%. So basically either we're just going to times that by 20 to get 100% of people. So that's going to be 60 people. Or I suppose we could say 0.05 of n, where n's the number in the population, number in the sample is 3. So again, sorting this out, divide by 0.05, n is going to be 60. So that's definitely right. So there's definitely 60 people, first of all. So that's what's happening in part A. It's just a little standalone question, getting us 2 marks. Okay. Now let's have a look at part B. A random sample of 20 is taken. Find the probability of these 2 things. So let's think about the distribution. N is now 20. My probability, n is 20. My probability of success is 0.05. You've either got red hair or you haven't. So here, if X is the number of people with red hair, it's binomially distributed. My sample size is 20, and my probability of success is 0.05. Okay. Part 1, exactly, and again, wording's really important in these questions, isn't it? Exactly 4, so that means I want the probability that X is equal to 4. So let's use our calculators for this. And that's going to be now binomial PD, because it's not cumulative anymore. It's not a less than or equal to question, it's just an equals to question. So I want to put a variable in, and I want my variable to be 4. N is 20. Probability of success is 0.05. And so what does that mean? The probability, again, I'm not sure if you can see that, it's 0.013327, etc. 0.0133. Let's just do that to 3SF. Okay, so there's part 1 of that question sorted. Part 2 of that question then, again, wording's really important here, isn't it? At least 4. So what does that mean? That means 4 or above, but 4's included there, so at least 4. So greater than or equal to 4. It's binomial, it's discrete. We can have 4 people or 3 people or 5 people. We can't have anything in between. So the probability of being greater than or equal to 4, to be able to use my calculator. And if we're unsure, let's just have a think about diagram. I want 4 or above, so that's the bit that I want. So I need to do 1 minus everything below that. So 1 minus the probability of x being less than or equal to 3. And now this is definitely cumulative now, so let's have a look in our calculators. I don't want PD now, I want my cumulative distribution because I want less than or equal to. I want my variable because I know the value of x this time. My variable now is 3. It's saved, the n is 20 and the p is 0.05. So that is 1 minus 0.9840, etc. Okay, let me just go back to my normal calculator then. 1 minus that answer is 0.015901. So 0.0159 to 3SF. Okay, and that's the second part of that question. Okay, now let's have a look at part C. So part C says, Patrick claims Redmond people have a probability greater than 5%. So this is important now, greater than 5%. So this is going to be one-tailed because it's not a change now. It's saying that Patrick thinks there's going to be an increase. So it's definitely one-tailed. Having red hair in a sample of 50, 4 of them have red hair. Stating your hypothesis clearly, test Patrick's claim, okay? Use a 1% level of significance. Let's just think about this actually. So 5%, if nothing's changed, 5% of these people would have red hair. So that's what, 2.5? So between 2 and 3 people, we've actually got 4. But is that, is that big enough to say there's been a change in the overall population dynamics here of people with red hair? And that's what we're asked to test here. If when I work this out then, I can do it 2 ways. I can either look at the probability of being greater than or equal to 4. Let's see what that is. And if the probability of that happening is less than, 1%, less than 1%, then it's significant. We can say, okay, yeah, there's been a change. If it isn't, then it's not significant. The other way of doing this is to look at the critical region, and we'll do that method as well. So I'm going to get a new piece of paper just to do this part of the question. Okay, so now we've got, if nothing's changed, it's going to be binomial, n is 50, and if nothing's changed, then we're sticking with this probability of having red hair as being 0.05. What's my hypothesis? My null hypothesis is that nothing's changed, that's staying like that. My alternative hypothesis now is that things have increased, there's more than 5%. Okay, and we're asked the 1% level of significance. So let's have a look. Method 1 then. What's that doing? That's going to look at the likelihood of getting, he's got 4 people, of getting 4 or more than that, because we're going at the top end. So the likelihood of getting greater than or equal to 4. Let's have a look. Probability that x is greater than or equal to 4. And be careful, because it's not this, because this was n equals, sorry, it's not this part of the question, because although that is greater than or equal to 4, you might be tempted to use your answer here, but that was only for 20 people. Now we've got 50, so we do need to have a look at that carefully. Okay, so that's going to be 1 minus probability of less than or equal to 3. Let's get our calculators going. Binomial CD, cumulative, variable, because I know the value of x is going to be 3. My n this time is 50. My probability of success is 0.05. So that's 1 minus 0.7604, etc. Let's just work that out. So 1 minus that answer is 0.2395. Well, that, you know, is about 24%, isn't it? So that is definitely bigger than 5%. So there's no significance here. It's got quite a big likelihood of happening if nothing's changed. So what we would say there is we'd go, well, there's no evidence of a change in the proportion of redheads or in the number of redheads. Okay, there's definitely no evidence there because it isn't a tiny probability. It isn't less than 5%, which would be significant in this one. Okay, what's our method 2? Our method 2 is to find the critical region. Because if we find the critical region and 4 is within the critical region, then it's going to be significant. So what is our critical region? Okay, it's a one-tailed test and it's a greater than, so I'm looking for at this top end, the bottom is 0, the top is 50. I'm looking at this top end, my critical value there, I'm going to call it C2 just because we call it that at the top end. I'm looking for this probability to be 5% level of significance. So I'm looking, 1% level of significance, I've just realised. So I'm going back here. There it is in the question. That should be 1% level of significance. So here I want this to be less than or equal to 1%. So again, let's get our calculators here. We're looking for this binomial distribution. I'm looking for cumulative, and I'm going to look at variable. Okay, and let's just write this down again so we get this right. This probability, a critical region, being greater than that value, I want that to be less than 1%. And again, C2 minus 1 here. This is the bit that I want, so if I'm doing 1 minus, it needs to be everything back here. So 1 minus the probability that x is less than or equal to that value below. Sorting that out, rearranging that. Again, reading this way. So the probability being less than that value, C2 minus 1, I want that to be bigger than 0.99. So let's get my list out. So I want binomial CD. I want my list this time because I'm trying to find out what value it is. I want to be the top end of this, and I don't know what that's going to be. So I can type in a few values over here where we know that, you know, 4 excuse me, is 0.2395, so that's nowhere near. I'm going to try 10 just to see. So that's 50 and 0. Just to see if I can see whether I want to go less than 10 or bigger than 10. Well, actually, look at that. That's 0.99999. So actually, the probability of being greater than or equal to 10 is definitely less than this. So let's go a bit lower than that. Let's try, I don't know, 7, 8, 9, 10. Let's try them. And again, these now are all big enough here. Okay. So let's keep going with that. Sorry, whoops. Let me just have a look at doing, cancel. Let me have a look at doing a few of these. Okay, so looking at these values, excuse me, looking at these values, then I'm looking at my critical region here, C2 minus 1. I want this to be bigger than 0.99. If you look here, the probability of being less than or equal to 6 is 0.9882, so that's no good to me. Probability of being less than or equal. So a bit of trial and improvement on here. is 0.9968, so that one is bigger than this. So C2 minus 1 is equal to 7, C2 is 8, so my critical region then is X is greater than or equal to 8. Patrick got 4 people, so that's definitely not significant. So we go back to this, there's no evidence of a change in the number of people with red hair. Okay, so that's question 2, done. Let's have a look now at this last one, question 3. And again, once you get back into the swing of these, they're all very similar. It's just making sure that you are, sorry, let me move these around, answering the question that they ask. So let's look at this last one. Shopkeeper knows that 15%, so my probability of success, 0.15 there, of customers buy an item from a display next to the till. After refurbishment of the shop, he takes a random sample of 30, so there's my N, and finds that only one customer bought an item from the till. Now, 15% of 30 is definitely more than 1. So let's see whether this is significant. So using your hypothesis clearly, 5% level of significance, so 5% of this, test whether or not there's been a change. And here's that word. So whether there's been a change, so it's going to be two-tailed. So not an increase, not a decrease, but whether there's been a change. Okay, and you've got to be careful with these in the questions. You can't assume one way or the other. And we're looking at 5% level of significance. So if X is the number of people buying things from near the till, X is going to be binomially distributed, 30 customers, so N is 30, probability of success, if nothing's changed, is 0.15. H0, my null hypothesis, is that it's staying at 0.15. H1, it's a change, so it's not equal to 0.15 anymore. So that's what we're looking at, okay? 5% level of significance, but it's going to be two-tailed. So that means that at the bottom end, C1, because it's a 5% level of significance, I want this to be less than or equal to 2.5%, and be careful with that because people often get tripped up on that. And at the top end, the same, I want the probability of this little bit, again, to be less than or equal to 2.5% because it's got to add up together to my 5% level of significance overall. Okay, 2 methods then. So the method 1 is finding the likelihood. So what's my likelihood of X being? This was 1, so that's definitely at the bottom end, isn't it? It's close to 0, it's down here. So, and it's less than what we were expecting because we were expecting 15% of our 30. So we were expecting, excuse me, 15% of our 30, we were expecting us to get 4.5 people, so between 4 and 5 people. Okay, so it's definitely at this lower end, but let's work out the likelihood of being 1 or worse than that. We've got to make sure we're doing or worse, and it has to be cumulative. So the probability that X is less than or equal to 1, sorry, get my calculator into view. We're looking for binomial CD. We know what the X value is, so it's a variable. 1, N is 30, probability of success is 0.15, so that is 0.048, blah, 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 about 4.8%. So that is definitely bigger than 1%. So there's a, at this level of significance, there's a decent chance of it happening anyway. So again, what do we say? We say that this is not significant. So we're not going to reject, do not reject H0. What does that mean in this question? It means that there's no evidence at the 5% level of significance of a change. So I'm using the wording of the question, of a change in the proportion or in the number of customers buying an item from the till. Okay, that's method 1. What's method 2? Method 2 is to look at finding these tails, to look at the critical region. So let's do method 2. What does that ask us to do? That asks us to find the critical region. Critical regions in this case because it's two-tailed. So let's do this. Probability that x is less than or equal to C1. I want that to be less than 2.5%. Or at the top end, the probability that x is greater than or equal to C2, I want that to be less than or equal to 0.025 again. Okay, so again, this time we're going to use our list. So binomial CD, I want my list this time. I want my probability to be less than or equal to 0.025 at this bottom end. Okay, so let's throw a few values in. I'm just going to put quite a few in this time. And I could do, you know, all the way from 0 to 30. That would be fine. I'm just going to put a few of them in. Let's go up to 10. Give it a second to sort itself out. So our probabilities here, I want my first probability to be less than 0.025. And again, I'm not sure if you can see from that far away, but my probability here, the only one there that's less than that is 0. So actually, this probability that x is less than or equal to 0 is 0.0076. Probability that x is less than or equal to 1, let's just tell the examiner that why I've made that choice, that's 0.048. Well, that's no good to me because that's more than this. So here is my critical value. So my critical value is x equals 0. My critical region is x is less than or equal to 0. But actually, there's nothing less than that. So we could say this, but that just means that x is equal to 0. That's my critical value at this bottom end. There's nothing else there. Let's have a look at the top end for completeness then. So this would be 1 minus the probability less than or equal to C2 minus 1, 0.025. I'm just going to move that across slightly. So 0.975. Probability x is less than or equal to C2 minus 1. So I want my value to be bigger than, my probability to be bigger than 0.975. Okay, let's have a look at my values. I put quite a few of them in, so I've hit one already. If not, I'll just throw a few more values in. Well, actually, I have, look, because there, the probability that x is less than or equal to 8 is 0.9722, so that's no good to me. But the probability that x is less than or equal to 9, that last one in there, sorry, on my screen, is 0.9903. So that is going to work. So what does that mean then? It means C2 minus 1 is equal to 9. So C2 is equal to 10. So here now, x is equal to 10. So at that top end, if x was greater than or equal to 10, then these are my critical regions for this one. What value did he get? He got that there was only one person that bought an item from the display. Well, that's not in the critical region. It's not 0. It's not greater than or equal to 10. So x equals 1, what they actually got, that's not in the critical region. So therefore, there's no evidence of a change in the proportion of customers buying an item from the till. Okay, so that's our 3 questions on hypothesis testing, and all 3 of them were past exam questions.